Welcome to this tutorial. This is QGIS 3.12, though we still have the latest QGIS, which is QGIS 3.18. So, but now this is QGIS 3.12, and the tutorial will be on introduction to QGIS. And also, I also want you to know how to get your own data because I have my data that I can work on, and you should also know how to get your own data. We have the shapefile data. We have the we have other data. We have SRTM data, that is the short radial topographic measure. It is used for extracting stream, and it is used for extracting contour. It is used for creating elevation map as well. Elevation map are just like height map. When we have a ground surface have different elevation levels. So SRTM can help to determine that. So also, when you talk about shapefile, there are different websites where you can download shapefile, but the website I do recommend is Diva GIS website. But before we start, let me introduce you to what GIS means. Now, let's see what GIS means, because basically GIS is a system designed to capture, to store, to analyze, to manage all forms of geographical data. Now, data can come in different forms. Data can come in terms of points. Data can come in terms of longitude, latitude. Data can come in front of a raw map, which we have to later transform into a digital map. Now, this is what GIS means. It's a computer system for capturing, storing, checking, and displaying data related to positions on the Earth survey. Now, GIS can show many different types of data on one map, such as streets, buildings, vegetation, and all that. Now, this is GIS. Now, this is the real world data. It transforms the data into a data model, then output. That is the data manipulation. Now, the data you collect from the real world, for example, let's say we collect the coordinates of a particular area. When we collect the coordinates of a particular area, we can process the data on GIS, which will give us a point data of that particular place. We can process it in form of anything. Now we can get a particular building data or high resolution data, maybe from Google Earth, from SAS planning, from any different sources. Then we can easily extract the building data, in form of polygon. If we have, let's say we have a building data like this, if you digitize around, you can digitize around it as a polygon. This is how a building will come out, a polygon, a point and a line. If we have a road data now, road data will come as a line, a river data will come as a line, then settlement data, places will be represented with a point. Now, components of GIS, we have the hardware, we have the software, and we have the data, we have the personnel. Now, when we talk about the hardware in GIS, we are talking about the computer itself, the computer equipment that we want to use to get to do our work. Now, if we want to do GIS now, we need our mouse, we need the computer, we need the printer. The system memory should have a good RAM. of at least between 3 gig upward. Then hard drive, the hard disk of the computer needs to be high as well. Now, because of the work, there are some GIS data that can be very bulky. Now we have the personnel also. Now, the personnel, they are the ones who carry out information on who are they? They are the ones who operate the computer, who operate the GIS software to bring out a particular result. Then we talk about the software. The software, we are talking about the GIS software. We talk about ArcGIS, we talk about QGIS, we talk about Idrisi, we talk about software, we talk about Smart GIS, we talk about Global Mapper. We talk about different GIS software for different purposes. Now data is the most important and expensive component of geographic information system. Data we need, that is the data we need for our work. We can get a raw data of a particular place and do the georeferencing and all that. So that is the data we need, data for our GIS operation. Then we have GIS data type, we have raster and vector data. Now, I want to draw attention to this. Raster data, they are in form of pixels. They are normal images. Like now, image, when we take image from a photo shoot, the image comes out and we see ourselves the way we are. That is an example of a raster data. That is an example of a raster data. Now, a vector data is always represented with point lines and polygon. That is, for example, if we take our image and change the image to a cartoon form, that cartoon form that is being represented like as if they are drawn with pencil and all that with template, they are what is called vector data. That is, for example, settlements will be represented with points, buildings with polygon, roads with line, water body with lines and all that. Then another example of raster data is the satellite image. Then also a high resolution image is also an example of raster data. Then the people and the methods, that is another thing. The methods, the GIS, the methods we use in carrying out the GIS work. Now we also have coordinate system. We have what is called coordinate system in GIS. Now we have geographic and projected coordinate system. Geographic coordinate is usually referred to as a world geodetic system. So it is always represented with the World Geodetic System 1984, while projected coordinate is the UTM zones, that is the Universal Transverse Mercator. Each country in the world falls into a particular zone. So each country of the world falls into a particular UTM zone, and it is very important for us to know that each country falls into a particular UTM zone. Now, this is what I'm talking about. When we talk of UTM zone, this is what we mean by UTM zones. It is in form of grids cutting across each countries of the world, each continents of the world. Now, each country falls into a particular UTM zone. You can see, for example, Nigeria falls between 32 it falls between 30 and 33 UTM zone. Let's say around it falls between 31 and 33. That is the UTM zone of Nigeria. You can see other countries. So Nigeria, that is the UTM zone where Nigeria lies. So between 31 and 33 UTM zone. So each country of the world falls in between a particular UTM zone, and that is very important. So, and in QGIS, we have different operations in GIS, and there are certain operations that cannot work that cannot work with geographic coordinate system, and there are some operations that cannot work with projected coordinate system. So there are some operations that only works using a projected coordinate system in QGIS, and that is, we also need to know that it is very important. So this is it. This is the geographic coordinate system WGS 1984, which is very important. So that is all we need to know. So there are some operations that won't work with a projected coordinate system, and there are some operations that won't work with geographic coordinate system. So that is what we need to know. Then there's what we call georeferencing. Georeferencing means bringing back a map to its normal position on the Earth's surface. Now, when you georeference a map, it's just like it's a means of assigning coordinates to the map. Now, if you do not assign coordinates to a map, if you take the map to Google Earth, for example, this is Google Earth now. If a map is not georeferenced, it will not locate the particular position it is on Google Earth. But when you have georeferenced it, you've assigned coordinates to it, by the time you want to use it online, once you send it to Google Earth, it will locate the particular position where it is on the Earth's surface. For example, if you are working on Nigeria, if I'm working on Nigeria and I want to work on Nigeria, I want Nigeria to display on Google Earth because I want to get some features. Once you have georeferenced the map, it will locate that particular place it is on this globe, on this Google Earth. Now I'm going to show you now. This is 5. So let's bring it in. I'm just showing it to you. I'm just showing this so that you can understand better. So here I'm going to change it to the format. So okay, now this is it. Now the reason why this map is able to locate, you can see it goes directly to Nigeria. Why? Because the map is georeferenced. That is the reason why the map was able to locate Nigeria. So this is it. You can see the main reason why the map was able to locate Nigeria on Google Earth was because the map is already georeferenced. The coordinate has been assigned to it. So that is the essence of georeferencing a map. Now, digitizing is just a means of converting a map from digital format to an analog format. That is the essence of digitizing. Converting a paper map. Once you georeference a paper map, you convert it to a digital map. That is the essence of digitizing. Then buffering is another operation which we are still going to look at in QGIS. So let's start with introduction to QGIS. We are going to look at the QGIS interface, and we are going to do georeferencing, and we are also going to do digitizing. So that is what we are going to look at. Now, the first thing I want you to know is that this is QGIS interface, and QGIS has plugins. Now, all these things you are looking at, there are certain plugins which I installed myself. Now, if you want to install plugin, the first thing you are going to do is to switch on your internet. Make sure your internet is on. Then once your your system is connected to the internet, you go to the plugin. Then you go to manage and install plugin. So it will come out like this. So once that happens, it will bring out all the plugins. You can see these are all the plugins that I've installed. These are all the plugins that I've installed. Now, if you want to install another plugin, you just go to all. So you can install other plugins you want to install. For example, I install database manager. There are some that will be automatically installed that you don't need to install again, but there are some that you have to install yourself. For example, time manager. This I don't really need this. So time manager, SRTM downloader is another one. Semi-auto clarification. You can see quick math services, QGIS cloud plugin. This is used for creating web map. This is used for creating elevation data. That is a provide tool. I installed that also, but not really common. Then this also. Then OSM downloader, QGIS. Then this is georeferencer. This is another one. This and this, they do the same thing, so this is better. QGIS is what we use for geocoding. Now that is how to install. So for example, if I want to install a particular plugin, just click on it. Just click on the plugin. Go to or just click on the plugin you want to install, then go to install plugin. Once you go to install plugin, it will come like this. It will download the data, then after that install it automatically, and after that it will install it automatically. Then before you know it, it will appear on your screen in QGIS. Now this next thing we are going to look at is this. This is the vector tool, and this is the raster tool. This is what you use for the raster analysis. These are the raster tools, and then you can also see it here. You can see different raster tools. Then we also use this grass. Now once you install QGIS, two will be installed. One will be just QGIS, then the second one will be QGIS with grass. So whenever you want to open it, just always open the QGIS with grass. That is the one you will be using. So now now I am going to show you how to download data. So the next tutorial will be looking at some other things. So I am going to end this tutorial by showing you how to download your data. Then the next one will be on georeferencing and digitizing. So the next thing I'm going to show you here is how to download your data. Now to download your data, just go to Google, type Diva GIS, shapefile. Now this is your Diva GIS shapefile. Now once you type that, you can see www.divagis.org. So if you want to download your shapefile, that is when you go there. You can see this is Afghanistan, different countries of the world. Let's go to Nigeria. This is Nigeria. You can download everything, the administrative area, the roads, the land cover, the population, and other. Let's go to administrative area. Then you click OK. So here you just click download. It will download automatically once you click on the download. That is when you want to download your data. You can see. So you will download it. So once it's downloaded, just open the folder, copy it away. From copy it to cut it and paste it in your local drive. See, make sure you always open a folder just to make sure your work is well arranged. Always make sure that you always cut and paste in your local drive. Then always create a folder just to make your work neat. So here I'm going to paste it here. So the next thing you are going to do is that you are going to unzip it. Just right click on it, then go to extract to the same folder, extract to NGA ADM the way it is. So once you do that, it will extract it inside this page. You can see this is the data. So once you have gotten the data, the next thing is to open the data here. Now, to open and bring in a data in QGIS, you go to layer, then from layer you go to add layer. So if it is vector data you want to bring in, you click on vector. If it is raster data you want to bring in, you bring in raster. And if it is the text layer, let's say point data, because in QGIS we are still going to look at that. Before you can bring in an Excel data into QGIS, you have to convert it to text, to CSV. That is CSV because that's the only thing QGIS can open, CSV. So you convert it to a CSV format. So here, if I want to bring in a vector data, for example, just click on vector. This will come out. Then here, I will select this. Then the next thing, I will go to where my data is. This is my data. Can go to where my data is. So here, for me to make this easy, you can see the data is too much for me. So for me to make it easier, just go to this place, all files, then change it to S3 file. So it will only bring in this. So one of these data is line. We have the boundary of Nigeria digitized with line, and we have the one digitized with polygon. So this is the one with polygon. So just open it, then close. You can see this is how to bring in data in QGIS. So in the next tutorial, we are going to be looking at georeferencing and digitizing. And I will also be sending you a tutorial on how to download, on how to open an account and download a satellite image from a particular website, that is glovis.usgs. So that is, I'm also going to show you that in case if you need your own satellite image, because satellite image is used for creating a land use land cover map, we are still going to do that. It is called image classification. So we use Landsat for that. So, and the Landsat, for you to be able to download it, you need to create an account with Glovis USGS. So for you to be able to access the download. So from there you can be able to download the satellite image of any area of any places you want to download. So we are also going to be doing that. So I'm also going to share you a tutorial on how to download this Landsat image. So thank you very much for this tutorial. I hope you learned some new things about QGIS. So bye till next time.